Yeah, 18 and 19 are two that, unless you specifically studied set and interval notation, it's unfamiliar. Now, we did do interval notation earlier this year. If you remember, yeah, we did it when we analyzed functions, looking at domain and range, and increasing and decreasing, all that stuff.
I do not remember. I did the wrong bracket and stuff.
We're gonna talk about it, but yes, we did. Because we would say like the domain is from -2 to 6. Remember we said it's a minimum, and then a maximum, and then the comma means everything in between? So don't forget, and this is an important small detail, but this comma for everything in between literally means every number. Everything. Every decimal, every fraction, every radical, everything is in between there. What number set covers every number that you've ever studied?
The number set.
So there are the integers, the whole numbers, the rationals, the irrationals, the reals. So integers are -3, -2, -1, 0, 1, 2, 3, and then go into either end. Is that every possible number? Whole numbers are just 0, 1, 2, 3, 4, 5, 6, 7 on up.
Wait, the other part of homework too? 1, 2, and 3?
Yep. So we need to recognize when we're talking about 1.7, that's a rational number. But the number pi, that's an irrational number. This number set that covers both the rationals and the irrationals is the real number set. Every number, every decimal, everything that you've studied so far is called the real numbers. So when we say -2, 6, we're saying every number, we're saying every real number. Okay? Now, Emily, this is to answer the question you had at the beginning, because you will see this again tonight. This curly bracket, so what this is, it's a curly bracket x. This means the set of x when or as defined by x being an element in the real numbers. So it's the set of x when x is an element of the reals. That just means x is a real number. That's it. And then you define what real numbers it is. -2 is less than x is less than 6. End of that set. That's what it means. That's how you read it. Does that make sense? And so that's why we said -2, 6, because when we use that interval notation, we're talking about the real number system. We're talking about every number in between. Yes, sir?
So with 26 and 27, the less than or greater sign determines whether the line and arrow go left or right.
Kind of. Because I do want to point out x is less than 6. That's the same thing as saying 6 is greater than x. It's the same thing. Because, look here, if I plug a 3 in, is 3 less than 6?
Yes.
Is 6 greater than 3?
Yes.
Plug in a 0. Is 0 less than 6? Is 6 greater than 0?
Right.
See how both of those are making both inequalities true? So notice what I just said is, these values make the inequality true. Any guess what we would call those things?
Absolutes.
Is multiplying supposed to be for the divide, for number 1?
Hold on one second. We're going to talk about that in just a second. So I need y'all to notice what we are shading is every value that makes the inequality true. That means we're shading the solutions. We've only talked about solutions for equations, but a solution for an equation is the value that makes the equation true. The solution for an inequality is the value that makes the inequality true. Now there are a lot of teachers who have just said, hey, the arrow is pointing to the left, so you shade to the left. But notice here.
I wasn't talking about the way it was pointed.
Oh. What are we talking about then?
I was saying like, so since they say the 6 is greater, that means the x is a lesser number, so
right.
Yeah, go towards the left.
Yeah. But, and what I would just focus on though is finding which set, the left or to the right, makes the inequality true.
Yes.
Right? Focus on what set of numbers makes the inequality true. Now, does anyone know why I did an open point here? Yeah, if there's a line underneath it, what does that mean? That it could
Not
greater than or
equal to.
If there's a line underneath it, it means that it can equal that number. So notice, if I were to have it just like this, is 6 greater than 6? That's why it's an open circle. Is 6 greater than or equal to 6? That's when you would do a closed circle. Does that make sense? Because that closed point means you can equal it. And that's an important thing to notice here. Notice this is less than or equal to. This is less than, and this is less than or equal to. Because parentheses are when it does not equal. Brackets are when it does equal. Right? So for example, if I were to do the set notation for this, or the interval notation, it's going to go all the way to negative infinity. And it's going to stop at 6, but it cannot equal that 6, so I'd use a parenthesis again. If it was a closed point, then I would use a bracket there. Make sense? Good with that? And that would just be the set of x when x is an element of the reals, right? It's got every number, that's why it's shaded to the left. And you would just say x is less than 6. Okay? You were asking, Zay, about 1 through 3?
No, it's about number 1, okay, it say divide by A, then say multiply by 1A.
Well, notice if I divide by a, what is a divided by a?
A. No. Yeah,
What's 7 divided by 7?
1.
C divided by c?
1.
So if I do a divided by a, it is,
1.
so notice how that is 1x is equal to 7 divided by a. Right?
Yeah.
Now, I could also do that as this, though.
A.
Remember how the reciprocal is also the inverse.
Yeah.
Notice, again, a divided by a is,
1.
so x is equal to 7 times 1 is 7 divided by a.
Okay.
So I was pointing out that you could divide by a or multiply by the reciprocal. Because that reciprocal is also 1 divided by a.
Yes, sir.
The same thing is true here for number 3. You could multiply by 1 divided by c squared, or you could just divide by c squared.
Yes, sir.
Any questions about that before we move on? We good?
Yes, sir.
Is that yes or no?
Yes, sir.
Cool. So we're going to look at today's objectives before we launch today's task. And then you're going to work in small groups most of today. Have y'all heard from Dewan yet?
No, I text him.
You can worry about him now. Alright, so we're going to launch today and we're going to do some small group before we wrap the day up. So objectives, we're going to be solving equations in one variable through using the properties of equality and inverse operations. Sound familiar? Isn't that what we did with everything of 4.1? So the process of solving equations, one of the most efficient ways is by using those properties of equality and the inverse operations. The thing that's different today though is this. Even when everything is represented by letters. I want you to see this though. Inverse operations, does that mean inverse numbers?
No
No, it's literally inverse.
operation.
So even if it is a letter, we're focusing on the operation, right? So if we're adding by x, I'm going to subtract by. If I'm multiplying by d, I'm going to divide by d. Notice even with variables, these processes stay the same. And that's what we're going to learn about today. We want to use units to understand scenarios and to guide the solution of multi-step problems. We need to use units to understand the scenario. I kid you not when I say I made it through engineering and even thrived in engineering just by paying attention to units. By making sure my units canceled out correctly, I made my life really easy, and so I want to do the same for you. It also helps us understand things. Alright, so here's where we're going to pick up. I already have this recorded, so I'm going to stop there on the recording.